I often get this sort of question over the years. I've gotten it many, many times, usually from people interviewing me for a magazine. If you had to do it all over, what would you do differently? And there's really only two good answers to that. One of them, of course, is nothing. And that was the Perl answer for many years. And the other good answer is everything. And that's more or less the Perl 6 answer. When we decided to do Perl 6, we decided, on the one hand, to clean up a lot of the cruft. No, we decided to clean up all of the cruft for our definition. So, in particular, when Perl started out, it was it didn't have a following, of course. So I had to borrow a lot of Unix culture into Perl, and a lot of that culture was already crufty, namely regular expression syntax, and we only made it worse. So that was part of our mandate to clean that up. But on a deeper level, we didn't just want to fix syntaxes. We wanted to fix all the fundamental flaws in the thinkos and the designos. So one of the major bad decisions that I made early on was to treat regular expressions as a kind of string. Instead, in Perl 6, we tried to treat them as a kind of language, more specifically a sub-language, and I'll get into what I mean by that. Here's a statement that you could make in either Perl 5 or Perl 6, but they mean somewhat different things. Declare a matched variable and initialize it. In Perl 5, it treats this as a string and interpolates that variable. And then it reparses it as a regular expression. That's bad. In Perl 6, it's just a language. And we'll see how that works as we go along. But it only does one passive parsing, and it treats it as a sublanguage. So when is a language not a language? Well, actually, when it's many languages. And so what we've discovered with the Perl 6 effort is that Perl 6 isn't a single language. Perl 5 is one language. That's how we thought of it. We're thinking that Perl 6 is many languages, or if you're British, Perl 6 are many languages. But in Perl culture, we don't tell you how to think. And people think in different languages. Well, actually, we want you to think that. We do tell you how to think. We just don't tell you what to think. Well, we do that too. Oh well. And what you should think is there's more than one way to do it, which is one of the Perl slogans. And that's my nickname, Tim Toady, is a pun on that. But one of the things that has always been the case with Perl is that you're allowed to talk at different levels of linguistic sophistication. We don't expect a 50-year-old to speak with the same diction as a 5-year-old or vice versa. So you're allowed to do baby talk. And you're allowed, in fact, to do cargo cult programming at the beginning. You don't necessarily have to understand it. You just sort of put the things there and bow down to them, and they do the right thing. And later, as you're going along, when you have to change it and it doesn't work, you have to learn why it didn't work. And then you start learning the underlying semantics. But I would like to say, or at least assert today, that the computing culture as a whole has gotten stuck in a level of cargo cult thinking with regard to parsing. Instead of that, I would like to think in terms of derived languages, where we don't copy and paste our compilers. Oh, I want a new compiler. I want it to be kind of like that one, so I'll copy the Yak grammar over, and then I'll start tweaking it. Instead, we should do something a little more modern. Polymorphism isn't that modern, but it's moderner than cut and paste. So, when you see when you want to parse something like this, instead of instead of a standard parser where you have a YAC grammar that's kind of fixed, and you just there's a special rule for this, and on you go. You know, you see some commonalities here. This is a different language than the outside of it. So when you're parsing at this point, you want to be parsing against a different set of rules than when you're out here. On the other hand, when you're parsing a variable, you'd like them to be using the same rule. You don't want to duplicate rules. Likewise, if you're going on to use double-quoted strings that do interpolation, here's a language where dollars mean something special and backslashes mean something special. If you change it to single quotes, it's a different language. And that's the way we're choosing to think of it here. So I bypassed this little thing here, which is how we're doing this. Regular expressions are, in fact, derived from the Perl grammar. Here, let me actually show you let me move this a little closer to the other workspace here. 12. Okay. Here's the standard Perl grammar. Don't worry about the comments in red if you can't see them. Now this is actually written in Perl 6. And it's probably nothing like any Perl 6 you've ever seen before, or nothing like any Perl 5 you've seen before. If you've seen Perl 6, then it'd probably be something like it. But it has grammars that are essentially just classes. So if I go down here and find the regular expression grammar, it is derived from the Perl grammar. And it overrides some of the methods. And off you go. And here's another example. Let's go back to when you're parsing quotes here, such as those single and double quotes you just saw. Here's the double quotes. Find a double quote. Call this special rule that is parameterized, and it's parameterized on the language that you want to parse inside. Start with the base Q language. Tweak that to have double quote semantics, tweak that to have a terminator of double quote, and parse that, and then look for a terminating double quote. The actual nibbler regular expression, using the term loosely, is right here. And so this is going to loop over all the characters. First it's going to, if it finds a whatever the stopper is, which in this case is double quote, then it quits. If you're doing nested bracketing sort of quoting, it's got to find a starter and keep the nesting straight and calls itself recursively. If it finds an escape, which is like the dollar signs, the backslashes, it handles those too. But again, it's polymorphic over whichever language you're dealing with. And finally, at the bottom, just grab another character and add it to the text. So that's one aspect of it. Another was that I'd like to describe is called transitive alternation. Here's another rule, which if I if I actually show it here, it looks like that in long form. It's got a label on the front of a statement and various modifiers, but in essence it's doing this. It says a statement is composed of a statement control or an expression or just a bare semicolon. Well, but that can be expanded out. An expression starts off with a term. And we actually have an operator precedence parser sandwiched in to the middle of a recursive descent parser. And that is what the operator precedence parser is going to look for first. So that's what that really means in terms of what we're looking for at that moment, the exact language that we're matching. Well, but that expands out if you're looking for a term, you're looking for some sort of prefix or a noun. And that expands out to various kinds of nouns and prefix operators, and on you go. The point of this is that Perl 5's alternation, the vertical bar, is not the same as Perl 6's. In Perl 5, in the Perl compatible regular expressions that everybody has borrowed, it means check the left thing, and if that doesn't match, check the right thing. It's like a short circuit operator. Instead, in Perl 6, we go back to sort of the original definitions of irregular expressions for DFAs, and single vertical bar is parallel matching of all the alternatives simultaneously, and then we use the double vertical bar much more consistently for the serial matching. But the question is, who wins when there's a conflict in these alternatives? Is the first, the oldest, newest? Is it a core rule that should match or easier defined? The problem with the core is Perl 6 is got this little problem if you're going to define it that way, is in that it has no core. Perl 6 has no keywords to the first approximation, and it has no built-in operators. Instead, everything is built up out of these rules. You can think of the entire Perl 6 language as just the result of matching a fairly fancy regular expression against a string. So this is the way you define subrules, and so the built-in operators like plus plus and plus just come in that way. Should user-defined operators take precedence over built-in ones? Well, maybe. If I define my own prefix symbol like plus minus, I can do that. Here, we can try it here. There is no plus minus in the standard grammar here, but if I have a grammar that is derived from the one you just saw, and I define a token plus minus, I can actually use that. And up here we see that we actually get a symbol plus minus. That's a prefix operator. So that actually, works rather nicely. But and that obviously it takes precedence over the plus operator. So it doesn't parse it as plus and then a minus and then that. On the other hand, suppose I define an infix CM operator. Maybe it compares two Roman numerals to see if they're 900 apart or something like that. All taking your afternoon nap, huh? Caffeine works wonders. Well, should user-defined take precedence? Well, probably not, because if there's a P after it, you probably want to do the comparison operator instead. I want it to do what I mean, which usually means that I want it to longest token matching. And we talk about this so much, is just shortened to LTM. Longest token matching is great, but what about, how does that play out with all this polymorphism? Because polymorphism means very late binding. So what it comes out to is that we need a just-in-time lexer for every language. Now we're considering the inside of quotes and regular expressions to be a different language. So it has to create those languages. Let's see, I already showed you the plus minus Perl sort of mini language. And where did I go here? But when I ran that, it actually it built some lexers here. It's hard to see, but there's a standard Perl lexer and there's a plus minus Perl lexer. They're just kept out as a handy cache. It could be all in memory. So if I go down to lex and plus minus Perl and look here, let's see. Yeah, just-in-time lexer. Okay, so there is, let's see, it's a prefix operator, so let's look at, see what it, under the prefix operators, it generated this lexer here, and we see right up to the front here is our plus minus operator that we defined in our derived grammar, plus all of the operators that came in from the standard grammar. This part of it can be matched by a DFA engine with the longest token semantics. And once we do that, it immediately knows, as soon as it matches that, what the next few steps are in the recursive descent parser. So it doesn't have to decide anything. It just cascades us down rapidly. And I wish I had more time to show that to you, but then I couldn't tell you about the other cool stuff. So, you know, there's an old saying, only Perl can parse Perl. And it sort of extends to Perl 6 as well. It's only slightly true because we're actually bootstrapping it in other languages. But we can at least modify it to, it's easier to parse Perl 6 than Perl 6. The fact is, all of these regular expressions, if you scratch them, they're just methods. It relies on multiple dispatch semantics and this concept of short and long names, where if I say match a prefix, that's the short name of a rule, but it's really standing in for a bunch of long names, where it's prefix this, prefix that, prefix the other thing. This auto-lexing with the transitive alternation, all these, every time you come to a new alternative, it hoists all these things up and builds a new lexer if it needs to for that. And all the alternatives are considered equal all the way down. There's no first class, second class operators. No built-ins versus user-defined. It's all on an equal footing. So when you see this this sort of an alternation, it all just works out, and it keeps hoisting it upwards. So so while we saw the yeah, I keep going the wrong direction. It's because I had it the other side before. I can fix that. Excuse me. Okay. If we go to the standard Perl lexer here and look at statement, did I use a statement? I did not. So let's. So I'll improve its generating on the fly here. I will parse one of the tests out of the test suite. It's about 8,000 bytes that parsed in about 4 seconds. So it's doing about, with no special optimizations, about doing about 2,000 characters a second at the moment. So now if I go back to lex Perl, let's see what we have. Okay, now we have statement 01, which is the first alternative inside statements. And we can see all the statement controls at the front there, just like the rule has. If we go on down, we see the terms that start off an expression, nouns, keep on going down, more nouns, prefix operators. And this is hoisted up that lexer into the higher level lexer. We're doing on time. Okay, time flies. Now, of course, I'm going the other direction. Don't have time to talk about back off on longest tokens. It's just a form of backtracking. But the ties are reserved by the order that they were declared. The longest tokens are, by and large, they're derived automatically from the grammar that you write. It knows which things, which matchers have side effects and which ones don't, and the ones that have side effects terminate your longest token matcher. But you can explicitly use this symbol, which is both a backtracking control and it essentially means this is the end of the token. If you don't match after this, it's an error. And these are all sorts of other things that Perl 6 provides, which I don't have time to talk about, but they're the sort of the boring things that are very useful in writing a grammar. I'd like to talk more about the handy stuff, about putting the regular back into regular expressions, and about how we've powered them up while we regularize them. And yeah, we expect people to steal these regular expressions like they did Perl 5's regular expressions. That's great. I talked about the difference between those. Got handy new backwhack matchers for horizontal and vertical white space. How often do you want to just say, well, I want to match white space, but I don't want to go to a new line if it don't match the new line. Things like that. In Perl 5, we discovered that extended syntax with white space between tokens was wonderful for readability. And it's so wonderful, it's now sort of mandatory. So you don't have to specify it. There's no more /s modifier because you disambiguate right there in the regular expressions. If you want to match not a new line, \n is match a new line. So by the rule that we uppercase the matchers that are negated, that's not a new line, and dot always matches every character. Similarly, we don't have modes on the multi-line matching. You use a different token for matching the beginning of the string versus matching the beginning of a line within the string. And it's very readable because it's right there. You don't have to look to the end of the regular expression for it. We've regularized all the brackets. Parens are always for capturing. That's the same. We've stolen the square brackets for non-capturing bracketing. We've stolen the curlies for embedded code closures, we call them, because they are. We've stolen the angle brackets for all the other, or most of the other meta notations. In particular, character classes are demoted to being inside of angle brackets, because usually in the age of Unicode, if you're using a character class, it's wrong anyway. So we'll give it a slightly longer Huffman coding. And since we stole the curlies for the general quantification, then we have our new notation that's much more readable, I think. And a cool quantifier. You can quantify not just based on a range of numbers, but you can quantify saying, as long as there is a comma between these things, match as many digits as you can. That should probably be D+ to match a sequence of digits. Word boundary operators that are directional using fancy French quotes. You can now use all of the non-alphanumeric characters are now considered potentially meta characters. So you don't have to keep a list in your head of, is this thing a meta character or not? Since we are not doing interpolation like strings, we can match whatever's in a variable literally, which is the right default, unlike in Perl 5. And in particular, back references match literally. So we don't have to distinguish between back references inside a regular expression versus outside. They now all use the same notation. Lots of other just very handy things that I don't have time to talk about today. Okay, but I really like talking about some of the cool things. All these languages that let you add new operators, they sort of tend to make you specify what the precedence level of those operators is. And for some reason, those precedence levels are almost always numbers. To me, that's a kind of magical constant that you shouldn't be talking about. So if you go back and look at the standard grammar here, where we define our operator precedence table. Somewhere here. Did I go find it? I must have gone past it. It's so short these days. Yeah, there it is. Okay. You'll notice our precedence levels are actually specified with strings here. And they just happen to end with equals because that makes it very easy to add a character, replace the equals with a different character, less than or greater than, and add more characters on the end. And so you can go on forever inserting new precedence levels. And you don't actually specify these. You just say, I want the same thing, the same precedence as a multiplication. Or I want it tighter than exponentiation or looser than an AND operator or something. So that's one cool thing. Another cool thing that we're doing in the standard grammar here is recognizing when people accidentally, it's going to be very easy for people, especially coming from Perl 5 culture, to use the Perl 5 idiom when it is changed to something more rational. So, oops. We check the various, most of the special variables are gone, for instance. But if you say, if you use this variable, $at, and it recognizes it, it will say you, $at variable, use of $at variable as an eval error is obsolete, please use $bang instead. There's lots of those in there. That's really, excuse me. It's pretty cool. And you also see some nice use of the switch statements in here. Which are not spelled switch and case, because that's talking about the constructs rather than just using natural functional words from English. One of my linguistic prejudices. Another cool thing is metaoperators. Assignment operators and negated operators, none of them are built in. They're all derived from existing infix operators as appropriate. And if you add a user operator in the appropriate class, you automatically get the assignment operators or the negated operators to go with that. Have built-in reduction operator. Take any infix operator, including user-defined ones, and put them inside at the beginning of a list, and it will apply that operator between each of the elements of the list. Hyperoperators, we have done a lot of thinking about various notations to support various kinds of parallel programming, and for vector processing and parallel lockstep kind of processing. Hyperoperators take any existing scalar operator and say apply it equally to both sides, and it can do that. And there's various ways of expanding out one side or the other if one of them is lacking in dimensions. These are all just metaoperators. Another cool thing is the use of what we call roles. Some of you perhaps have heard of Smalltalk traits. We've incorporated that idea into Perl with some extensions and christen them roles. So we also use that concept within the grammar. Where's a good example? Yeah. For example, when we derived our quoting languages, different quoting languages have different sets of backslashes, for instance. And here are the backslash sequences for double quotes. And there, you can even define roles that will take them back out again, simply by defining a role, a rule within that gets mixed into your grammar that just has a failure, and that hides the original thing. So you can just pull in these things as you will, as you're defining new languages with different various sets of features. And here's your basic Q role, which defines the essence of single quoteness. And none of this is hardwired into your compiler anymore. Okay. Ratchet and sig space. Usually this shows up as the difference between most. Okay, if you write a normal regular expression, we see this as a regular expression here, then it has semantics more or less that you expect. This star here does backtracking. It's greedy. It's going to match as many posts as it can and try further, and if it can't, then it backs off. If you instead are looking for a token, then it turns on what we call ratchet mode. I don't see a good example offhand here, but in that case, well, here's one. Okay, we're looking for some number of traits to parse, and in this case, it parses them all. But if this fails, it's not going to backtrack and try shorter ones. That's what we call ratchet. Sometimes it's called possessive quantifiers, and that's the default within tokens. Rules are what's a good example here? The rules are just like tokens, except that anywhere there's white space in here, it also allows white space within what is matching. So it's good for matching things at a higher abstraction level. So up here, you're getting more into sort of the YAC frame of mind, and assuming that a lexer has already dealt with the white space. How are we doing on time here? Okay. I'll go about 5 more minutes here, and then we can have questions. But the really cool thing that's going on here is that for so long there has been this deep divide between the people who wanted to do DFA matching in this pure computer science sense, and the sort of a lot of the practical people who like the NFA matching because it gives them a great deal of power and flexibility, but you have to worry about the order things happen because it's really a programming language, not it's really it's more procedural than it is declarative. But what we have here is the opportunity to mesh these in an almost transparent way, with the longest token matcher automatically pulling out everything that makes sense to match with a DFA engine. And it can run very fast. And then as it gets to a certain point, it switches over to the NFA semantics, which can have very powerful actions and very powerful assertion semantics. And most of the time, you don't even have to worry about it. It just happens. I think that integration will turn out to be quite a powerful idea. And we're still exploring the ramifications on it. We now just parse the whole, we slurp in the whole program. We got lots of memory these days, and almost never does the program exceed your amount of memory. So we don't, pull in a line at a time and then count the line and somewhere down in some rule or other, we have to increment the line counter, and if it gets off, it's off. We just know where our position is in the buffer, and if we get an error or something, we just count the number of new lines before it, and we know our line number. We don't even really parse ternary operators here. The rule for parsing the ternary operator just treats it as a real fat infix operator that happens to have an expression embedded in the middle. And it's this is calling into the rule that happens to be the operator precedence parser. And as with any rule, since they're all just methods underneath anyway, they can be parameterized, and we've parameterized it with the maximum precedence level it's allowed in there. And if it doesn't get that, then we know fairly accurately which mistake they made. You know, they put an assignment inside where it doesn't make sense, something like that. And a lot of this is designed to give a very useful compiler to the end user, to give them a message where they don't have to scratch their head for 5 minutes to try to figure out what went wrong. Another notion that we have here that has not been thoroughly explored yet, but is the idea of suppose points. As you're going through and doing a parse, oftentimes you'll come to a spot where you say, well, the right way to parse it is this, but it looks like they might have made a mistake here. I don't know if they did or not. They might mean this. So we will suppose that, that they knew what they were doing, but we'll remember this. And if somewhere later on we get a panic and start and we got a parse error, it's going to come back to here to this suppose point, and it's going to say, well, what if they had written it the other way? So we do a hypothetical parse at this point, going forward again, and if it gets further than we did before, we can be almost certain that that is the mistake they made. Now, we don't go as far as a lot of the compilers in the 1960s and try to fix it for them. That would be bad. But we can give them a very, very good error message. We'll skip that. We're all over Unicode, so we prejudice things in terms of assuming that we don't just chop our \x's after 2 characters. That's sort of a 8-bit assumption. We're biased towards characters, so it'll chew up as many hex digits as you can. Just little tweaks like that. But my overall thesis is essentially no computer language has ever taken extensibility seriously. They tend to fall into the fallacy of any color as long as it's black. As language designers, as a class of people, tend to think that they know how it ought to be, and try to impose the one true syntax on their users, whether that's lots of silly parentheses, or mandatory white space, or various other ways that language designers go wrong. And I think I'm pretty much out of time here. Yeah, it's time for questions.
So when will Perl 6 actually be released?
Pardon me,
When will Perl 6 actually be released?
That's the usual question. The usual answer is Christmas. We just don't say which one. The flip side of that is after Perl 6 comes out, every day will seem like Christmas. So, seriously, we've made an awful lot of progress. You can see that I'm actually running a parser here. It's still pretty buggy. But I'm actually, what I've got here, I mean, there's other people who've written other parsers that are sort of hardwired for standard Perl 6. I'm trying to do the parsers right according to this polymorphism and longest token matching. So that's my field of expertise. And so I'm working on compiling this using this. And it actually will compile several hundred bytes into this before it blows up now. And the way I'm doing it actually is I've got a chewing gum and baling wire program called Gimme 5, which takes the standard, it's really, you don't want to do language translation like this. But for a one-shot translate this specific chunk of Perl 6 to this specific chunk of Perl 5, it does that. The only thing it does a real parse on is the rules and the tokens. And then, so this standard grammar is, 100,000. It's less than 4,000 lines, and that's got a lot of comments in it. And if you want an idea of the sort of power we're adding with the notations, translating that to Perl 5 ends up with 45,000 lines of code, which ends up looking like this. So a little teeny rule like this. This regular expression foo ends up turning into interesting an interesting bit of code there. And there's other ways to write that, but this is just a convenient way to do the backtracking. And it's very inefficiently written right now. Right now, the notation is assuming all over the place that you're doing backtracking, even though most of these things are tokens and are guaranteed not to backtrack their quantifiers, and that could be optimized very easily. And but for bootstrapping purposes, 2,000 bytes a second is probably enough. So we're making progress, and to get way back to your original question, I talk like a politician. You know, you give me one question, I'll give you a different answer. I'll answer the question I want to answer. But it'll get done when it gets done. But my lookout is just to make sure things continue to converge. And as long as they're converging, this is not like a business project where you have a burn rate, and if you don't get it done by date X, you're just dead meat. It's an open source project. It's all volunteer labor. It happens when it happens. But as long as it's converging, it will happen eventually. And then hopefully we'll be happy.
I'm curious if you've had an opportunity to do any performance characteristics between if you wrote something using the new Perl 6 syntax versus Perl 5 and with the new indirection layer for parsing and lexing.
Well, right now it'll be a lot slower because we haven't got any of the engines to run the full semantics yet, and we're sort of prototyping it here and bootstrapping. It is certainly the case that we bear potential performance in mind down the road, and that's part of the reason we want to do the longest token matcher thing in a DFA because we know that's very fast, and that will control the parts of a recursive descent parser that would be very slow, which is probe this, probe that, probe the other thing, keep backtracking. We're just doing away with that every time we recognize a token. So we expect it to be very fast. Now that being said, computers are getting faster, and that's an old argument. But a lot of the theory for parsing was done sort of back in the dark ages when people were trying to shoehorn parsers into small memories and slow CPUs. And they tended to warp the language in favor of the computer rather than the user. So just as for instance, a Yat grammar, something goes wrong, it can't tell you much more than syntax error, near here. With a recursive descent parser, you can give much better feedback because you know what you're looking for. And if we can make a recursive descent parser that is largely recursive descent, at least for the tokens and high-level stuff, and sandwich operator precedence and where it makes sense, then we can give really good error messages and get most of the performance too. And we think that's a good disruptive technology kind of trade-off.
Perl already is like a really free language. One of the drawbacks is that when a language is so free that over the years as you write this thing, you get a really wide set of things to know to be able to understand what's going on in the code. When Perl 6 comes out, we have a way of having polymorphism for everything that it does. So what are some of the ways that we can kind of stop it from being like wildly out of control
Yeah, that's a fair question. I think that by and large, it comes down to a cultural question at that point. And we've already seen with Perl 5 that the culture tends to enforce use of the strict pragma and the warnings pragma, so much so that we made that default in Perl 6. And they'll come up with other things like that. Another take on it is, on the one hand, we try to provide maximum flexibility, but on the other hand, we also try to provide you with a better idea of what you should do by default. We discovered this with Perl 5 object system, which is exceedingly orthogonal, and in fact, too orthogonal in the sense that it gives you no obvious way to do it. So the Perl 6 object system is, you can do whatever you want with it underneath, just as with Perl 5, but on the top of it here, it's got, there's a standard way of declaring attributes, a standard way of declaring methods, and so on and so forth. And if there are fairly decent ways built in to do most of what you want already, then the temptation to roll your own becomes less. So that is sort of, one of those oddly ironic things that a language that is providing more flexibility would also try to prevent you from using that by giving you a way to do it already. But by putting those making those sort of good default decisions in the base language, it takes a lot of pressure off of the need to roll your own. And I think overall for most tasks actually reduces the learning problem. But other things we're doing is actually rethinking also the way the documentation interacts with the syntax, so that we can intermix almost in a literate programming style the documentation such that it's accessible. So that if you derive a grammar, everything is first-class objects in there. You can go in there and ask the object, "What do you know about yourself?" In ways that other languages have explored even more than Perl has. We steal good ideas wherever we can find them. So there's no simple answer to that problem, but we have thought about it.
So we've talked mostly about the parsing of Perl 6.
Mm-hmm.
You talked about the running of it with like paired VM and like that.
Yeah, I can talk about it. I mean, most of these bullet items that are one line are each talking their own selves, and people talk about their various VMs and such. And Parrot is one of the VMs. It's perhaps going to be the main VM. But Perl 6 as a language is VM agnostic. Probably the Parrot VM has the longest running effort, but their mandate is not just to make a VM for Perl 6, but a VM that will be good for most any dynamic language. I actually have had very little to do with the Parrot VM. At the beginning of the Perl 6 effort, the community sort of said to me, well, you know, we know how you implement. We've seen your Perl 5 code, and it's pretty darn ugly. So, you know, but we'll do the implementation. You think about the language some. You know, actually, at the very beginning, was just the community was going to do everything. You know, I was just going to sit back and watch. But after a few months of trying to do community-wide language design, and you know, we asked for RFCs, and I expected about 20 suggestions. Got 361, and they were just all over the map, and mutually contradictory. Each of them had tunnel vision. They were going to leave Perl 5 the way it was and fix this one thing. So of course, if we just implemented them all as suggested, it would have been a complete hodgepodge. So we had to sit back, and the community came back to me sort of hat in hand and said, we need a language designer. So I've mostly been concentrating on the language design. It's only just recently that I've gotten back into implementing just this part of it. So I've kind of stayed away from the implementation end of it.
So, is this live? No.
It's Memorex.
So what happened to Audrey?
Audrey Tang, who was working so rapidly on Pugs and demonstrated how to get people to really get going on IRC and just sort of do 24/7 programming. And Pugs is the result of that. And it's, to this day, as a semantic prototype of Perl 6, it's the most advanced. And it's starting to show. Audrey came down with severe hepatitis, and to the extent that it was basically life-threatening, and her doctors, I mean, she has, among other things, attention deficit kind of problems, and was, you know, on stimulants, and she had to stop taking those stimulants. So she still works in the background, but she wants to keep a low key, and you know, we all, unfortunately, as we get older, run into times when we have to learn to pace ourselves. And you know, she hit a brick wall that was solider than most of us. I've hit a few of those myself, but it's never entirely happy making. But she's doing okay.
What would be the level of compatibility with Perl 5 modules with Perl 6?
Okay. We've got several stories on that. One of them, is simply that we'll be doing a certain amount of Perl 5 emulation. Worst case, running a Perl 5 interpreter in the same process. Best case on that is shared run loops, so you don't run into problems of stackful run loops. And the other leg of that is that we already have in prototype Perl 5 to Perl 6 translator. It was done a couple of years ago for Google Summer of Code, and it's probably had seen a little design rot since then. But in principle, most Perl 5 code can be translated to Perl 6. That doesn't help with the XS modules that interface directly to C or C++ code, but that would be something that you would probably use emulation for. And the translator is also going to be good for educational purposes, even if it doesn't actually get used for migration. I found this to be the case with the Octoperl translator and Sed2Perl when I first came out with Perl 1. I delayed the release a month or so while I wrote those translators because I thought it would be better accepted. And people did use them a little bit for actual migration, but by and large they would just type in something they were familiar with and see how it came out. And it's probably what will happen with this translator too, but it gives people warm fuzzies to have it there. But usually what we find is people get excited enough about the new features and syntax that they really want to rewrite it and take it as an excuse to refactor everything. And when this much code turns into this much code that's more readable, they like that. If you run a translator, it comes out usually a little bigger and usually a little less readable.
Have you been heavily involved in the summer of code stuff? And if so, what have you liked and disliked about it?
That's a good question. I was actually the mentor for this translator. What I discovered was I am not a good mentor. So I am not mentoring this year. But that's my problem, not Summer of Code's problem. I am somewhere on the autistic spectrum, I think, and I don't do certain social interactions like initiation that is crucial to being a good manager. The only reason I managed to run this open source project is that I have learned to delegate even the delegation to other people.